Yes. Hello, everybody. Good morning. I think we're going to do, Haythan's going to give a presentation on the new Auth integration that he just checked in, big check-in. And then Haythan's going to go through some deep dive analysis that we did on performance of Propeller under a lot of stress and load, which he's been working on for a while. And then we open it up for future design topics, any other questions that people have along the way. So do we have any new people visited before?
Yeah, I see Tom is, we saw him in the channel a couple of weeks ago, I think.
Well,
yeah.
Welcome. All right, Haythan, are you?
Hey, yeah, sorry, kids. So good morning, everyone. Let me share my screen here. I think I'm sharing the right screen. So yeah, I would like to talk today about the Flyte Authentication project we worked on over the past few weeks, and why we started to do this in the first place. So if you have tried to configure Auth today with Flyte, some people have successfully done that, but in most cases, like they need a lot of help on our side because the configuration, some of the configurations are not obvious, and it's not quite clear what the where to put what, like which settings to set where, and what they should point to, and so on. And add to that, it only supported external IDPs. So if you have, Okta or Keycloak or, Auth0 or, one of those services that do support a wide range of protocols, we require like OpenID Connect, Auth2, and so on. But if you have just a simple requirement of enabling, Google Auth or Microsoft, live accounts, I don't know what they name them now. Yeah, it just will not work. It does not support that. Yeah, and then the configurations are complex. And if you just like do one mistake somewhere, you don't know, the errors were not obvious. What did you do wrong, and so on. And after that, you had to enable and disable Auth at every ingestion point, like in Flyte Propeller that talks to admin needs to know that it should enable Auth or not. In Flyte CTL, in Flyte CLI, like every client that talks to admin needs to know if it should or should not use Auth. It's not like configured in a central place. So we, Praful, I, and Yi set out to try to change that. With few goals, and first of which is it should be easy to configure. You shouldn't need a lot of guidance. There should be documentation that tells you what to put where, and it should do it in one place, right? You should be able to just configure Auth in admin where Auth is enforced, and then all the clients should just know that, and start prompting Auth or login messages. The second of which, it should be standard compliant. We didn't want to like reinvent the wheel or have our own Auth, weirdness or store credentials or like any of that, because then you get into this rabbit hole we'll probably never get out of, and we're bound to make mistakes there. So we want to keep it standard compliant. We also wanted to support simpler services that just offer like SSO with OpenID Connect, like Google Auth and so on, but do not offer like an external authorization server that lets you protect your own services. And then we should also keep what we had, which is being able to configure to work with those external services if you choose to. Right, and that's the end of slides. I wanted to go over the like a simple set up, and I had the docs. So we did try to extensively document how do you configure. Let me start from the home page here. So there's an overview of which protocols and which flows that we support. You can go over that. There are links to specs if you are inclined to read them. But you don't have to. And there's a simple link on the top that walks you through configurations for some of the popular services. And contributions here are absolutely welcome. If you have configured it to work with Keycloak, please put the configurations, other services. I would love for this to be a very give a canonical example of how do you do it for each of those popular services, so that the next person would find it easy to do so. We did go through that exercise for Google. Google implements OpenID Connect. It's compliant to the standard. And Okta also does that for OpenID Connect. You can just use it for OpenID Connect, or you can also choose to use it for as an external authorization server to protect the other endpoints in admin for app authentication. The configurations have changed quite a bit, hopefully for the better, and I will let you be the judge of that. We'll go through the simple example of how to configure, Google Auth, for example, right? So when you start up a simple sandbox now, after 0.13 is released, it will come up configured most of the configurations you need for enabling Auth, but Auth will not be enabled by default because it requires you to add an additional step to link it to some credentials you create at Google or whatever IDP you use. There is a link here for how to do that for Google, which I believe I can go to. So it goes, you can read up on Google's docs on how to create credentials. Go back here. I did that previously, but it's simple. You can go to your I think it's cloud.google.com. You authenticate as yourself, and this is all free. If you have just a personal account, you can still do that. And you say you want to create credentials, and it's of type Auth 2 client credentials, which we also tell you to do. And I created one for Flyte admin. You end up with a client ID and secret, and a new bunch of URLs here to where it can go to. Obviously, this works with the sandbox. If you have a deployment with the real URL and DNS and so on, you should configure it as such. Yeah, so back to here. We just left a note that you can do it with Keycloak. Soren did. I just didn't get the time to get it set up and write down the actual configuration how to do it. If you did, please contribute. And then it goes through how do you configure this. And at a high level, there are two things you need to do, right? You need to set a secret somewhere, and we use Kubernetes secrets for that. The client secret we just looked at. And then you need to tell admin, you should start enforcing authentication now and use this service, right? Like Google and so on. The secret is simple commands here. And if you can try to go through them. Oops, I thought that would zoom in, it didn't. Okay, so you can say kubectl edit secret and Flyte admin auth. Oh, sorry. The deployments now come with empty secrets that will populate the first time you you like start the admin deployment. What's next? All right, let me just set my kubectl here. There we go. And so all the secrets, like there's no secrets checked into the repository. They're all generated for like unique to each deployment. And they stay as such. Like the first time you deploy this, it will generate new secrets, and then after you update admin or whatever, they will just remain the same. It will not reset. Existing login sessions and so on will continue to work. But we just want to make sure this is we don't like leak secrets or people start sharing the secret or whatever unknowingly, and you know, and we compromise like deployments. Yeah, so if you looked here, we already generated those 3 secrets. They are used for you know, various things, cookie encryption or claim encryption in certain tokens, and it tells you to add a secret under string data. And don't worry, yes, we are pasting a plain text secret, but oh, this became too big. Sorry, zoom out. Okay. The Kubernetes, once you save this object, it will immediately encode it and encrypt it on the server. I think I can copy from here. Give me a second. Copy from a real browser. Here we go. All right, so it provides this convenience access, I guess, to plain secrets. You can add plain secrets. Once you do, once you save this object, they will get encoded and so on and converted into this data field. So let's save this. Oops. All right, so now the secret is there. Next, we need to configure admin to start enforcing authentication and tell it to go, you know, to do that against Google. This is a bit awkward, but to find the config map that's currently used with Flyte admin, you can do this dance where it searches the current deployment for this string. And the reason we do this is because every time you change the config map in the deployment in customize, we generates like it hashes the contents and generates a new name, and it does that so it forces like a restart on the deployment if the only thing you changed is a config. But then the side effect is you end up with those random name config maps. You don't know which one is currently being used. Yeah, let's edit this. And you will notice here there's now a section that will come with any new deployments after 13 called Auth, and it has a lot of configuration already filled in. Some of those have default values configured in admin, but others here that that we think are common to be edited are configured, are like displayed. There is authorized URIs. This is what URLs you can like access admin from, and currently it comes with like the the ingress endpoint for Sandbox, as well as internal endpoints that are used within the cluster. If you have like obviously a DNS, you should add that here, so it allows people to like redirect to those URLs to for the various authentication flows. And then there are two main sections below that. There's an app auth and user auth. So user auth is what we have been talking about so far. This is what we use for that was supports like SSO essentially, and the only current protocol supported is OpenID Connect, and it's filled in with some dummy values for Google Auth, but you should replace this client ID with the one you created at Google here, and pretty much leave the rest the same, right? And then you flip a switch that says use auth. Just say yep. I'm just doing the changes in line here. Ideally, you would change this in your customized deployment and you redeploy, so you have it in a consistent state. But you want to assume. And then you can restart admin. And if we did everything correctly, now if I visit Flyte admin, it should trigger Auth, which it did not. Oh, there are other errors, I think. Whoa. Upstream Connect. I'm having, I think, ingress problems.
It's still restarting, I think. Try again.
Oh, that could be. Yeah. Okay. Let's see. Looks like it's running, and it redirected me to login, but I am unable to access that. Okay, I will look into that. That's what makes a live demo, right? I will look into that afterwards. But yeah, that should be all you need to just do OpenID Connect. I will not go through the Auth 2, but if you have a server that supports an external authorization server, examples again are Okta or Keycloak. There is documentation here for how do you configure Okta to be your app auth provider, and that lets you do things like so admin comes with this simple implementation of this. But if you configure Okta, you can have a standardized dashboard for all your, the company apps, and you can disable those apps in a central place. You can enforce a consent screen, so every time somebody tries to authenticate with a new app, it will ask the user for do you approve this app of sorts, right? So it gives you a lot more fine-grained controls. And Flyte is not an identity provider. We don't want to implement any of that. They do it much better. So so you should do this if you have depending on the configuration in your company, and then it goes through telling you how do you configure that in for admin. And again, this is all you will have to edit, and then the other clients will just start prompting the users. If you're using CLI, it will just start prompting the users to authenticate and consent them or whatever. It will discover the right authorization server and so on through admin. We added a few new endpoints in admin to make this discovery easier. If you are coding a completely new client on your own, we should talk. We can show you we don't have documentation on how do you do that, but I think at some point we will. But we can show you at least the existing patterns to use, so you don't hard code any assumptions in your clients, and yeah, make it all discoverable. I think that is all I have. And if you have questions about authentication or how do you configure stuff, please you know where to find us. Thank you, and back to you, George.
Hey, Haytham, I had a question.
Yes.
This is Santosh. So how is this different if you are enabling a user to authenticate who might be there in an IDP versus a service? Let's say Airflow wants to submit a job, or maybe an ML platform wants to submit a Flyte job. Is that going to also go through IDP itself, or how will it differ, if at all?
Yeah, that's excellent question. So yeah, you can configure. There is a concept of a service account flow in Auth 2 IDPs, and yeah, you will go to, and again, this will not be hard coded. This can be all discovered, all the URLs to go to and so on can be discovered through admin endpoints. But yeah, you will go to the IDP, you get a token through your credentials. And then that will issue you a token, and then you can submit this against admin. The reason it's different is because most of SSO or OpenID style stuff are more complicated than just the username password. You will maybe prompt the user for a two-factor auth and send them a text on on their phone and so on, right?
Yeah.
And you can't do any of that as a headless service running or Airflow server or whatever. So they are different, and because they are different, it lets the administrator who is configuring the IDP decide which like permission levels they can get. For if you are just a service showing up with the username and password, maybe it'll give you like very limited permissions versus a user who can get like a wider range of permissions or like their full set of permissions.
Mm-hmm.
Does that answer your question?
Yeah, yeah. So you're saying that will be a different flow, but that's also supported.
Yep.
Okay. All right. Sounds good. Thanks.
I believe we have a section down there for like CI. Yeah. How do you, like, we have I think this scenario, have a CI or style, some service running in cron job or whatever doing this. How do you configure that?
Sounds good. Thanks.
I have another question. So what's the time frame? When is this already in, or?
Yes,
yeah.
So all of this is merged. The remaining PR is this docs, the docs PR. So hopefully this will go in today as well, and it will be
awesome.
accessible.
Awesome. Yeah, that's cool. Because I mean, I have with Keycloak, as you said, but with the old way, which was a little bit more painful, or I had to ask you all the things. And but if this is in now, I think I'll try to upgrade, and then I'll add Keycloak documentation. I just didn't want to add it for the old setup.
Yes, please. That would be awesome. Thank you. Yeah.
Yeah, so we'll be releasing today or tomorrow 0.13, and that should include this like as the entire platform level through everything. One thing, I don't know if it was obvious to everybody, but this is full single sign-on support across everything, across CLI, browser, like everywhere. You usually is not available in most open source software. So when I was looking at the PR, I was like, holy crap, this is, mind my language, that the PR was huge. And I was like, we are implementing a lot. Yeah, but the way it's been done is it's almost a standalone service that you could use for authentication across other products if you want, as a gateway. So it's pretty awesome.
Thank you, Nathan.
Thank you.
Keithan, I think you're ready to go if you want to start talking about
Sure.
open heart surgery on Propeller.
Mine is not going to be as interesting as Hitham's. It's more of there's no demo per se, but we'll talk about performance. I've seen some questions from various people about performance, like how do you alter it. So most folks, when they start off with Flyte, it continues to work, is what I've noticed, and then it continues to scale also for decent workloads. But then you start running it for extremely large workloads, and then there could be problems. And so it's important to optimize the performance at that point. And so what I'll do is I'll try to walk you through how do you reason about the performance of Flyte, and how do you really try and tweak it and improve it for your specific use cases, and what are the things we're working on further. So for anybody who doesn't understand the Flyte architecture, here's a quick, very short overview. Essentially, we have the user plane where it's all the SDKs, console, and then we have the control plane, which is essentially storing all the inventory data, essentially all the workflows, all your executions, recording it, showing it to the users. Both the user plane and the control plane are not really in the performance critical path. And when I'm talking about the performance, I'm actually talking about how fast is it to execute a workflow, to schedule a job, to run a node, and so on. And this is by design, that they are not absolutely in the critical path. There is one flow that is in the critical path, and we'll talk about it. Though the user plane has, if you're not using Flyte Copilot, if you're using the Flyte Kit or Flyte Kit Java, they have their own data management system. So they do download and upload the data on their own. That is different performance, in my opinion. That is the performance of actually how fast you can get data from S3 or write to S3, or and can we use caching over there? That's not what I'm going to cover in today's topic. This is purely the engine performance. Okay, so that's what I did define. And so one of the things is like, the reason why we went with the design of Flyte in the way that we'll talk in this way, where we'll see the details, is because we are not just scheduling pods on Kubernetes. We are scheduling pods on Kubernetes. We are scheduling jobs on SageMaker. We're scheduling jobs on BigQuery, and we wanted to actually optimize the entire performance as well as security of this entire system. So that's a few reasons why we decided to follow this path of developing Flyte Propeller. So again, before we try and dive deeper into the performance, let's recap on what exactly happens when you start an execution. When you start an execution, Flyte admin is the endpoint that you communicate with. Now, Flyte admin, we call it like one service is essentially a bunch of services grouped together into behind a REST/gRPC interface, behind one ingress endpoint. Today we write it like a monolith essentially, but you could imagine that it could be easily split up into multiple. So let's think about the execution service. Well, it's called the execution service from the UI CLI. What happens over there is it retrieves a previously compiled workflow closure, converts it to a executable format, and currently the executable format is targeted towards Kubernetes CRDs. So it actually generates a CRD object and then submits it to Kubernetes. When it's doing this, it's actually also taking the inputs that you passed in, dispatching them into the right system, and converting all the objects so that like converting the graph and doing a final kind of a smoke check on the graph and running it onto the Kubernetes. This is not touching any of your containers. This is not touching any of your other metadata. So at this point, what has happened is now the CRD is available on Kubernetes. What happens next is we run this thing called as a control loop. Control loop is essentially comes from control systems, right? It's you want to.
What is a CRD? Sorry.
Oh, sorry, no worries. So CRD stands for Custom Resource Definition in Kubernetes. And please ask me questions if I'm going over some of the concepts. So Kubernetes, in my opinion, Kubernetes is essentially this mega service that allows you to define resources, arbitrary resources. And some of them are first class and some of them are second party resources. The first party resources are essentially pods, containers within pods, deployments, services, and so on. But Kubernetes allows you to extend that API to add other services. Like you can now say Kubernetes run a Spark job, Kubernetes run a query in BigQuery, Kubernetes run whatever. And what the beauty of that thing is, then it allows you to specify a control loop or an actor loop for a specific definition. So let's say I wanted to check the weather every few minutes. You can actually write that as a CRD within Kubernetes. I will not get into the details of how to do that. That's a complete different session. But essentially, you can extend the API, and then you can use kubectl, kube clients, and all of the known tooling to access those services.
Got it. Thanks.
Yeah. So what we did is we essentially made Flyte workflows as an CRD. Now we are debating whether that's a decision that needs to be done at the moment, because one of the things we wanted to do initially when we started is like make entire Flyte system completely composable. So Flyte workflows with Flyte Propeller can be run independently. And so if you wanted to bring in a separate workflow engine, you could, and you wouldn't get all the power of Flyte, but you could, re-implement some of the protocol and you would be able to run it. The other reason why we did it is because Kubernetes offers a very easy way of writing control loops, and rather than easy, a canonical way of writing control loops. And what are control loops? So you, whenever, like I said, let's take the example of I want to run a job. This is the request that comes from the user. We call this as the desired state. And then the actual state of this is to run the job. But the running the job may require us to, let's say, pull a container first. So you would first say, go pull a container. And that may take a while. So you could yield control. And then after some time, you can again look at the desired state, which is like run a job, and the current state, which could be pulling a container or maybe container pull completed. Then we might say run a command line empty point or something within that container. And this is a hypothetical example, but that's what a control loop is. It's you're constantly looking at the desired state and effecting an actual state. And whenever you look at the, before you create an effect on the actual state, you look at the current actual state, diff it with the desired state, and do only the diff bits, right? So this is a control loop. It's a very simple pattern that is very effective because it's resilient from failures, right? Anytime the desired state and the actual state drift, you can reconcile them to bring them together. So, but how does this fit with Flyte workflows? What we did is we modeled Flyte workflows as a desired state that we want to have an execution of the workflow. And the actual is to run every single node within the workflow. The desired really is the output of a workflow, right? That's what we are saying. Here's a workflow, generate the output. And Flyte Propeller is the one that's running the control loop and constantly evaluating and fixing the actual state, which could be run the nodes, run the task, run a BigQuery, all of that stuff, and then effecting the actual, which is the output, which may take hours or days. And it's okay, it keeps on looping over and doing this again and again. So if you know loops, there is one interesting thing. This is a common pattern that also happens on your phone every day, in your TV screens, right? You are constantly running loops. You're reprinting the screen. It's static images that are run so fast that your eyes cannot make a difference between that this is actually static or is it moving. And this illusion of movement is because you make every frame, that's what we call it, or every loop run so fast that and so many frames run within 1 second that your eyes cannot make a difference. So that's called, this is the rule of most, or the holy grail of rendering a beautiful thing. You run it at 60 frames per second. But the same thing doesn't quite literally apply to us, but it applies in some sense, where you want to make sure that the loops run really, really fast. Because if the loops can run really fast, we can run lots of loops within 1 second. One thread could do, if you could do 60 frames per second, then you could do 60 loops within 1 second, right? And that means you could run 60 workflows in 1 second, and you would think that they are all running concurrently, or with the 1 second delay. So how does that relate to Propeller? So basically, in one loop in Flyte Propeller, this is what it does. It loads the entire workflow specification. It loads the previously recorded state, which was the workflow in a running state, or what the workflow running a BigQuery job, or so on. It observes the real world state. So it may call BigQuery and say like, hey, is the job running? It actually works with the data in some cases because it has to collect the data from upstream nodes and pass them down into the downstream nodes. So it has to materialize the inputs essentially. So it may have to do that. It may calculate the difference between, I wanted to run two BigQuery jobs, one after the other. And the difference is I ran the first one. So the difference is I have to now run the second one. And then it may also, after doing all of and then it may effect a change. That means it may run the second BigQuery job. And then record that I ran this BigQuery job. And then finally also informs the control plane that, hey, I have done all of this. Go show it to the user or go show it to the observer. This seems a lot. It's a lot of work that it has to do within one loop. Doing this in super tiny amounts of time is extremely hard because if you think about it, it's reading data from multiple databases. It's reading data potentially from other services which have low throughput limits, like maybe BigQuery doesn't even allow more than 30 requests per second. I'm giving an example. I know some services that don't. And so how do you make that work? What do we, again, why is the performance can be slower? Because, loading and storing can be slow, observing can be slow. And one thing is true, we have to create an effect. And again, remember, creating an effect is like launching a pod, launching a query. The goal of Flyte Propeller is to do all of these things. So the performance penalties over here, there is no way of hiding that. It's just going to happen. But everything else, we can do something about it. And let's see what we do. So first thing, Flyte Propeller, if you start reading the code, you'll just notice there are caches everywhere. The reason why we have so many caches is because we want to hide the penalty of loading data from any remote system. But caches are dangerous, right? Like we all know that caches can be very dangerous. The only way caches can be dangerous if you start mutating the data behind the cache. So Flyte Propeller works on the principles of immutability. Almost once it touches a data bit, it never touches it again. So let's say it works on a node and it generates an output. We know that that node's output will not be regenerated. So we just store the output in a place and we never touch it again. Now, when I'm storing it, I could cache it through a write-through cache, so that subsequent reads are accelerated. Same thing happens when you're reading data. If you know that it's not mutated, you could just cache it in memory using a read-through cache, and then multiple downstream reads will be much faster. So currently and I'll show you some graphs in the end. There are graphs available for all of this. The observed or the desirable cache hit rate is 100%. It's impossible because we always have to generate new data and so on. But we observe upwards of 90% in cache hit. The second thing that happens is how fast can we inform the control plane about, hey, I have observed this, I'm done. This happens for every single node transition, every single workflow transition. So this is one place where the control plane is in the critical path. So if your control plane goes down, Flyte Propeller will pause. It will stop sending events and it'll start making progress. And the reason is because we think if you cannot record the progress then into the final state, observable state, then it's essentially useless progress. So there is no need of making that progress. This doesn't mean your jobs, if they're running, will halt. They will not. Only the recording of the progress will be halted. So this usually is less than 10 milliseconds. One of the ways to solve this problem is make sure your database is well sized. So if you're running large workloads, then the Postgres database should be decent sized. Don't run it on a T1 micro and expect extremely high performance. But rule of thumb you can look at the graph again. The latency should always be less than 10 milliseconds. It's usually in the single digit milliseconds of 4 to 5 milliseconds in P99 case. Another thing is use some sort of service mesh. If you're within KX, the default KX proxy will bind to one host on admin, and if you're running hundreds of thousands of workflows, it will be a problem because that actually becomes a network problem within that one host. The second thing is, how do you make the effect? There is no way out of doing the effect. So the only way to do it is to make sure that you can create as many effects as you can within 1 second. What that means is you should have higher bandwidth communicating to Kubernetes. So if you're launching 100,000 pods, you should be able to launch 100,000 pods at in a reasonable amount of time. The default Kubernetes client is configured to do only 20 requests per second or 10 requests per second. So if you calculate by that and you want to launch 100,000 pods, it will take a long time. And that's not really Flyte Propeller's fault. It's essentially KubeAPI is protecting itself from launching too many pods. Same thing is true with BigQuery. Same thing is true with all of those things. And what Flyte Propeller does is essentially creates a barrier around all of these services so that you don't brown out any of these services. It will rate limit everything. This PR has a bunch of these tweaks in the documentation, and it's getting merged soon. It tells you that how do you upgrade let's say the Kubernetes client. We have safely increased the Kubernetes client to do more than 300-400 requests per second, but that's not required. 300-400 is pretty high. You can just do 100 with a burst size of 50, and that works really well. Another thing is you may, if you're running your own Kubernetes cluster, make sure that the etcd is running on an NVMe drive so that the performance of etcd itself is pretty good. The other thing that, and these are all like, some of these are already implemented internally. So what Flyte Propeller does is, like we said, that we have to actually fetch the workflow and we have to fetch the state of the workflow. So instead of just directly fetching the workflow from Kube API always, we have a cache. It's a pattern called as the informer cache. These are in-memory caches with the workflows in there, and they are asynchronously synced. And they are synced using a stream protocol. So every time somebody creates a new workflow, Flyte Propeller doesn't poll for it. Flyte Propeller just gets it using a stream API, and it keeps it in memory after that point. We've also taken this pattern and further implemented it for all external services. So if you use the Flyte plugins web API module, or if you use the Kubernetes API module, we are automatically using informer caches for all external services. So what happens, essentially, the idea is that if you're using BigQuery and you want to update the status of the query all the time, instead of calling BigQuery, you consult the cache. And the cache updates itself asynchronously from the background. And that way you can have limited number of queries going to BigQuery. And even if you are not really within the loop of checking the cache, you will asynchronously be updating the cache. So next time when you come and check the cache, it's an in-memory lookup. It's extremely fast. The other thing that we realized was that, but caches come with eventual consistency, right? You bring in caches, that means asynchronous cache especially. That means you got everything into the cache, but you have to wait for the next cycle to get everything into the cache again. And that causes redundant loops. What that means is, like, every time you run a loop, you may not have an update. And you may actually be looking at all the stale data. So to prevent that, we actually use an interesting thing within the system. So etcd stores everything as a multi-version concurrency. Is a multi-version concurrency data store. That means everything is versioned monotonically almost. So what we do is we look at the version numbers and we play a trick. If we know that our version number is older than the last written version number, or it's equal to the version number in our cache, we just drop it on the floor. We say that we have to wait for the sync. And this reduces the total number of cycles we are running, and that interestingly improves the throughput of Flyte Propeller. And this one is another thing we realize, is that when we actually effect a workflow, we know the full state of the new updated state of the workflow. What that means is, let's say I ran 4 nodes. I know that I ran these 4 nodes. I know they were launched, 4 BigQuery jobs were launched. I know that they must be running now. So I don't really need to wait and retrieve the result from etcd. What we have it in memory. So as long as Flyte Propeller continues to run, deployments will change that. But as long as it continues to run, it uses this in-memory copy to run another loop. And it does this as fast as it can to make sure that the workflow can make as much progress as it can, while also being resilient from failures, because it always records the state in between. And this can be adjusted using max streak length. Again, it's part of the PR. You have to be careful with it. If you make, so I'll give you an example. Let's say we have a 3-step workflow where all the 3 steps are memorized. Then you probably, if you set the max streak length to whatever n, which is maybe 15, it will go through the entire workflow in less than 5 milliseconds or 10 milliseconds, or some number which is dependent on cache lookup speed. Flyte Propeller is also a single, runs as a single process today in the default mode, and it uses Go routines to run multiple workers within it. And Go routines, if you know, are not threads. They are IO. They are like they use the concurrent scheduling pattern, and so whenever there's an IO, it will yield to another Go routine, and hence you can run lots of them in if you have a number of cores. So let's assume you have 4 cores, you can run 500 workers. But it doesn't mean you can run infinite number of workers, because there's only diminishing return after some point. So again, in the PR doc, we have an example of how many to run, how to alter them. Default is around 20, but you can easily change them. We have tested around 500, and it works absolutely fine. The other problem that you will see, and this is a user problem, I mean a user facing problem. They create a workflow which has a very high span out. What that does is, for one loop now, I have to, let's say I have completed the start node. Then in my next loop, I have to evaluate all of these nodes in parallel, sequentially, one after the other, because Flyte Propeller only runs sequentially for one workflow. Then if you have 100,000 nodes here, it will take a long time to evaluate them. Specifically, if you're causing an effect, let's say you're calling Kube API server. Now there is a rate limiter on Kube API server, and you can only do 10 requests per second. To go through all of them will take a long time, and that will slow down the refresh rate, hence cause jarring, and look, performance is slower. So the solution for that is we limit the total concurrency on how many nodes within one level can be evaluated by Flyte Propeller. And this is already in. We just have not exposed it through the execution endpoint, and we're going to expose it on the execution endpoint. So when you launch an execution, you could say, I want some cap on the max concurrency, and there will be global defaults. But the other better solution in this case is to use what we call as map tasks. Map tasks are interesting, especially when the same task is repeated hundreds of thousands of times. So let's say you are trying to build a model for 10 regions or 100 regions or 1,000 regions, or you're trying to build the map of the world and you are break the world into like 100,000 pieces. It's essentially running the same job of mapping, and you are passing just different data. So a better way to do that is run map tasks. Please refer to the documentation for it. The reason why it's more efficient and effective is because there is a very simplified state storage that happens within Flyte Propeller. Instead of taking many megabytes and kilobytes, it stores in sub 10 kilobytes on the entire state, which is an optimization that we have done, and I don't think anybody else does it. It was done specifically for map tasks. Another thing that it does is it automatically enqueues. Instead of running them in parallel, it enqueues by creating a concurrency control in there. But besides loop performance, there are a few other things that you have to be careful about. One is the size of the workflow itself cannot exceed 2 megabytes. And this is a limitation on etcd. Etcd max object size is only 2 megabytes. And so we've seen that this gets breached if you have a task with unique tasks in thousands of tasks, or if you have an individual task where you use extremely large queries. And I've seen queries which are in hundreds of KB, that not even tens of KBs, which can, you add a few hundred of those queries and you will basically breach the threshold. But a solution for that is use dynamic workflows. Dynamic workflows don't use the etcd cache, etcd store to store those. They get offloaded to blob stores. So that makes them really possible to write extremely large workflows in dynamic workflows. And coming later, we are going to offload all workflows. And what that does is allows you to not rely on etcd's dependence. Okay, so now was a lot of stuff. What do you do? Do not optimize anything till you measure. So we publish a bunch of Flyte dashboards, and here's them on Grafana Labs. Just download them, install them, and use them to understand the performance of your Flyte deployment. We are following a model for having the best defaults, which are like any other system defaults that work in most cases. They may not be the most performant, but they will get your job done. So we're doing that throughout the system. This PR will get merged soon, which actually gives you these knobs that you know, or gives you a documentation to know which knobs to tweak. And don't be shy to ask on Slack. This is complicated stuff. I completely understand. It's deep. It can be very deep. So please ask questions. As a benchmark, I ran this on a single propeller with 2 cores and 2 gigs of RAM. We ran about 10,000 workflows concurrently. And what I had done is created a fake load that actually blocked a worker in Propeller for 1 second. It just put it to sleep. So if I have 100 workers, if I start running 100 workflows, 100 of them just sleep for 1 second. Even with all of that, we had an overhead of less than 9 seconds for completing all the workflows, which means it was purely blocked on the 1 second sleep. In conclusion, like one propeller is freakishly fast. You can really run more than 10,000 workflows in one propeller with minimal memory footprint and CPU usage. And there's only 2 CPUs. You can raise it to 4 CPUs and increase the RAM and increase the number of workers. But that's not enough. We need to scale out. Flyte Propeller already supports sharding by namespace. That's trivial. Just add the -- namespace flag. Or we are actually working on using KX leases and dynamically scaling up and down based on the load. We've not done that because it makes it complicated for users to understand any kind of failure scenarios. So look out for that. But by the end of mid or towards the end of the year, we should have this out. We should automatically scale up. We still think the bottleneck is going to be Kube API. So we should work on that a little bit more. But other than that, we should be able to run hundreds of thousands of workflows concurrently. And that's it. It's a deep dive. These slides will be shared. And please ask me any questions.
Thank you very much.
Hey, Ketan, if I am a workflow owner, does this help me in identifying bottlenecks for my workflow? And for me, the simplest model is that I wanted 100,000, I requested 100,000 containers. I got 10,000, and it's kind of blocked on that one because other people have taken the resources. But can I see where my workflow has been kind of not getting enough resources and therefore not progressing fast enough using this framework?
Yeah, so the example dashboards that that we have shared on Grafana Labs. Let me again share my screen. So this dashboard, there's a dashboard called as the user dashboard. This was actually a problem that Adam on the Slack channel had like 2 days ago, where he had a workflow that was running very slowly. According to him, he was running 1,000 tasks, sorry, and they were running slowly. And what the reason was not Propeller, the reason was the Kubernetes quotas for the namespace that we had were set to be very low. They were set to be like 10 CPUs or something, and so you could not use more than 10 CPUs. And so Flyte Propeller was backing off, saying that there's not enough CPUs available. But if you look at the user dashboard, it does come up with, let me open up the dashboard. So you can actually start finding your workflows here, right? It's not showing anything because you're not running anything. It's a demo cluster, but it can show you the current quota usage for your project and domain combination. It can show you current task stats, how many are pending and what's happening, how many system errors.
I don't know if I've seen this one or not, but effectively, does it show that my workflow actually needs 10,000 tasks, or it is basically my tasks are waiting? It shows like what is being executed, the fact that overall quota, how well it is utilized or how much of headroom is there. But does it actually show that my workflow needs X amount, and out of that X, 25% has only been allocated? That's the kind of thing that I wanted to know about.
Oh, like the current progress is what you want.
Current request versus current allocation.
Yeah, so that it should show, right? Like this is the request versus limit, right? This is the max usage versus the actual head, the cap. What I think is the other thing that you probably need is in the console, we have actually been working on some improvements to the console, and they should, not to the console, but to the backend system, to actually show you more details of when you run a workflow. So if you run an extremely large workflow, you may want to, I just want to find an example. It's always hard to find one. Okay, I'm not finding one. But like for extremely large workflows, we do show that these are all queued. We are improving the messaging in there. Like, why is it queued? Like, for example, is it waiting for resources? Is the GPU is not available? Are you trying to schedule for 6 CPUs and the max number of CPUs on any nodes in your cluster is only 2? So we can't really schedule it. So all of that is coming in the UI. It's available in the control plane. It's just not shown in the UI. The UI is a little behind.
Okay, sounds good. Thanks.
Great question. Anything else? Cool.
Yeah, one information I needed.
Yes.
So actually in my company we were using Netflix Conductor earlier, and I saw that more of the basic components are same that Flyte is using, and but I can see Flyte has this cache and everything you showed. That is pretty good. So is there any comparison study just to get a benchmark or something like that?
We are actually working on publishing a comparison, but we won't be comparing with every single.
Yeah, I can understand.
It's extremely
Just to get a benchmark.
Yeah. So from my point of view, Netflix Conductor is more of a microservices orchestrator, and Flyte is more of a workload orchestrator, slightly different.
So actually, we used Netflix Conductor as a base. We built on top of that to make it use as a MLOps also.
Okay.
Yeah.
So this is the first time I'm hearing somebody using Netflix Conductor for that. So it's great. But yeah, as you can tell, I won't be able to I don't think the community will be able to compare every single schedule, but we will be comparing with the majority, and which we have been doing. Like one of them is Airflow, another one is that we've been comparing with is Argo, I think, and another one is Kubeflow pipelines or something, which is Argo.
Is it there in documentation of Flyte?
No, we're just finalizing, right? Like
Okay.
if you notice, nobody else has compared anything, because you have to be comprehensive and clear, and so we are trying to be as correct as we can. We'll also come with recommendations, essentially, like if you're running some sort of queries where you don't need data to be passed or so on, probably Airflow is better, right, in terms of the maturity of the ecosystem. And yeah, so we'll be doing that. Please stay tuned, and if you can help with comparing us with Netflix Conductor, we would love to help you get the data and compare.
Yeah, sure. Thanks for that.
Yeah, for a timeline on the comparison, let's say by the next meeting we'll have at least a draft in the documentation, which is 2 weeks from now.
Good.
Anything else? By the way, Suraj, which company do you work for, if you don't mind sharing?
GE, General Electric Healthcare.
Oh, awesome. Nice to see you guys.
So yeah, we were looking into Flyte, and I think if we find it better, we'll migrate to it.
Oh, thank you so much. Yeah, let me know how we can help. We can also do a deep dive on a total session for you guys, just so that you guys can ask, understand all the differences. Okay, so yeah, performance related problems definitely raised to us. We care deeply about the performance. This has been working at scale at Lyft and other places. So, but it's performance is always a progressive problem. Like on day one, you don't feel anything. On day two, you probably feel a little bit, and then when you really are going to run 100,000 workflows or something, that's when you start feeling it. So we want to help you get that point smoothly.
Sounds good.
Cool.
Thanks, everyone. I want to be sensitive to not going over an hour if we can. So we're pushing. That was a lot of information. It was a great overview, Keithan, of just how Propeller works, which was super. So not only the performance, but it was good conceptual overview from. That's up. Anybody want to present next week? Please drop Sandra, or 2 weeks from now, drop Sandra or me a note. And we'd love to see some of your stuff in your internal implementations, especially, and see what crazy things people are doing. Thanks everybody for joining.
Thank you.
Hi, everyone.
Bye, everyone.